Today I want to share several things we learned today. We had a lot of experiments. It's like controlled experiment where you fix everything but change only one variable and then repeat the experiment just to find when it fails and when it's good, right? So first thing we find is if we train this model with more data, then basically you can grab the blue cube from anywhere in this white paper. Day before yesterday, when you had the first version, we only trained to pick up from 3 locations, and it can only do that 3 location pickup. But now we trained with a more randomized location across this whiteboard. We collected 50 data, and now we can basically pick up from anywhere. So I will show you the video. It's 2 times faster play speed. And the cool thing is that it tries to pick up from the top, right? It goes to top and make sure it goes like almost 90 degrees to pick that up. And in this case, it fails, and that's because this blue cube is out of the range that it can reach. Okay, once it's within the range, it can still pick up. Just like this. It's good, but now soon you will be able to see some failure cases. So the one before was out of range, and this one it fails, but we found why it fails. Basically, it almost always fails when the cube is right in front of the arm, and then we are curious why it fails when the cube is right here, right? So this is the second thing we learned. It turns out the body is black and the gripper is black. So when the gripper is here, there's a camera, one at the top, one at the front, but from the front camera, it's kind of difficult to distinguish where the gripper is, right? Because it's black and black. I'll show you in a video like this. So the the object is here. Let me find the episode that we collected. This is training data. Yeah, let's say object is here. And then when the gripper comes here, it's kind of difficult to distinguish this gripper and the body, as you can see, only from this front view camera. Now we need to rely on the top view camera. But unfortunately, from the top view camera, because of the robot arm, we cannot see the blue cube. So that's why this was one frequent failure point. It was like 50-50 that sometimes you success, sometimes you fail. Right. So that was our second learning, that we maybe need a different color for the body or gripper. And third thing we learned is about the background change. So when you change the background, like we put different objects, sometimes even person is moving here, dancing behind this robot. Or sometimes you put the hand between the camera and the robot. So camera has a lot of occlusions. And then I shake the hand like this, just like this kind of occlusion. That's all fine. But somehow at some point, we found that the robot is failing again and again. And that was very similar to the uh, second learning that we had. So this is just an example. When the cube is here, during test time, I was standing behind here. I was standing like basically I stand here wearing black clothes. And when the robot comes to here, now it cannot distinguish the gripper and my black cloth. Imagine background here is all black, right? then it's difficult for the camera to distinguish. So that's similar learning. So we also need to distinguish the color of the gripper from the background. In this case, it's also similar. The cube is blocked by the robot arm. And that leads to our fourth learning, which was very interesting. When we collect the data, we had the front camera and top view camera. And then we changed many things. I will explain one by one. But one thing we changed today during the testing was that we block each camera completely. So each camera has black frame input. But still, to some extent, the robot can grip the box. And when you make the front camera black, this one, then it almost always fails. But if you make this top view camera black, it's kind of working. And I think it's because this top view camera anyways blocks the blue cube frequently. So the trained model relies more on this frontal view. So I guess this input has more weight in the neural network than the top view, right? That was very interesting learning. Yes. So I think we can design the camera location and angle, and also the arm location and angle with caution, so that the operation that the arm is doing is clearly visible from the camera. Also, during the training, we can mask out one input randomly so that we drop out the camera. And I think that will also improve the stability of the network training. Sorry. And the fifth thing we learned is we also changed the location of the camera a lot. Let me go to here. Yeah, for example, as you can see, there's a top view camera. We move the camera left, right, up, down. Even we change the angle, it didn't affect much. So you can basically move few centimeters. It's not a surprise because I just told you that when you block the top view camera, it can still work, right? So top view camera I can understand easily. How about the front of view camera? I don't have a, oh, I have this guy. So this is the front of view camera. Basically, we move the laptop left, right, up, down, and we also tilt the angle of the monitor. And then we found that we can move 1 centimeter, 2 centimeters safely when we move this laptop left, right. Left, right, what I mean is that it goes from here to here, here to here. Okay, so that's left, right. Or let's say from this viewpoint, let's say top down. Go top down, okay? But when it goes to left, that was a big issue because when the laptop gets farther from the this cube, the cube becomes smaller in the camera scene. And when it becomes smaller, the robot thinks that the cube is far away from the camera, right? But then during the training, we never change the location of the laptop. So robot thinks, let's say the cube is actually here, but since the laptop went to the left side, gets farther and smaller, in order to be smaller in the camera, in this setting, actually the cube should be here. So robot try to grab the cube from here, right? Not here. So that was the one thing we learned. So it's not scale invariant. So I think it's also a good idea to add training data for different scale. But another idea is just to fix everything, fix the whole setup like arm and camera, they are fixed with frames, so they almost never change. They only change like 1 centimeter or a few degrees when you move the frame from A to B, right? So that was how many? Is it fifth or sixth? I don't know. There was a sixth learning, and also this tilting the camera angle, the laptop. It it did not affect a lot. We can safely move few degrees. It can still work well. All right. So not every variables in the environment are critical when you do the inference. So now we kind of understand which variables are critical. We haven't tested all the variables. For example, we haven't tested the orientation of the robot, right? So those things, more things we need to test, but basically we kind of know that if we make a frame, then what are the important variables that we control precisely, and what are the things we can make a room for a little bit of error and slack, right? Because if this, let's say this setup requires like a very precise, like 0.1 centimeter and 0.1 degree sensitivity, then we need to make a frame with iron, metal, right? That will never change anything, right? But then if it's like a 1-2 centimeter, a few degrees, okay, then we can kind of just make something that's less solid, right? So that was a good learning today. And we also discussed further about what kind of task we want to do. We are thinking about testing. What I mean by is that you test certain electric object if it works or not. For example, light bulb. So you hold the light bulb, let's say, and then you put it to a light bulb test, and then light bulb will, it should be like turned on. But if it's not turned on, then it means it's a defect, right? So you need to throw this away. So that kind of thing, we got the insight from Igor and Victor because they actually have a manufacturing factory which involved making some lights. Right? So I think it could be a good test case. I hope it's easy to test because this tester we need to control to test the light bulb with the tester. We need to control the orientation of the light bulb quite well, so the light bulb can fit into the test slot correctly. So if we can solve that, I think it's one useful real world use case. Okay. Did I miss something? Yeah, I think also last thing was a shadow. So shadow seems it's not critical. It does not like make a miserable failure of the robot movement, but it kind of affects the precision of the robot or shakiness of the robot a little bit. Yeah. Oh, and another experiment we did was actually we put these cubes. We have different color cubes now. Then we put this cube and then see what happens. We only use the blue cube during training, and then we put the white cube, for example. The robot get confused. It's something, but then it's not blue, so it's like it tries to grab or not. But when we put the orange cube, it maybe is very difficult, very different from blue, so it didn't even try to grab it. Well, it doesn't mean much, but yeah, that was also one experiment we did. Mm, yeah, I think that's all today. Um, yeah, yeah, I think so. Okay, so it was a great day, and we'll from now on we'll try to maybe make the frame to make the every experiment more repeatable, and also we start to make the test environment. If you can do the light testing just like people do in their factory, they'll be really great. Yeah, that's it. Okay.